Let's look at 103 and 104 here. Now, 103, you could look at that, and if we look at the trig substitutions to make, you might say, let's see, we've got constant minus variable, so that's going to be this guy. So you want to let x equal 3 sine theta. And that would work. You could go through, do this problem with trig sub, no problem. But notice this. The thing under the radical is 9 minus x squared, and the derivative of that is going to be negative 2x. Well, that's a multiple of what's up here, which means we can use u substitution instead. And u substitution is much quicker. So let's do that here. We'll use plain u sub. So let me erase this under here. You let u equal 9 minus x squared. Du then is going to be minus 2x dx. And then let's see, x dx. Going to divide both sides of this by negative 2, like that. So now I can rewrite this as 3. X dx gets replaced, or well, let's do 3 over square root of u. And then x dx gets replaced with minus 1/2 du. All right, so I'm going to rewrite this. I'm going to bring the minus 3/2 out front. Integral of u to the minus half du. So let's see, if you integrate u to the minus half, you get u to the positive half. Then you have to divide by 2. Or, no, you divide by a half, which is multiplying by 2. And so we wind up with negative 3 u to the 1/2. Let's just go ahead and rewrite u as 9 minus x squared plus c. I guess I should have a plus c there too. So anyway, if you can get away with using u sub instead of using trig sub, definitely go with it because it's quicker. All right, let's look at this next problem. This one is a little different because instead of just an x squared, we've got 16x squared. So what's happening here is this is my u squared. So that means u is 4x. And a here is 3. So we've got u squared minus a squared. So we're going to use the secant. So for my substitution, I'm going to let 4x equal 3 secant theta. Now let's see, derivative of, or take the differential of this thing. I could move the 4 to the other side, but I'm not going to. The derivative of 4x is 4. Derivative of 3 secant theta is 3 secant theta tan theta d theta. And the radical, that's 16x squared minus 9. Well, 16x squared, that's this guy squared. So that's going to be 9 secant squared. So I can pull a 3 out of that, and I'm left with secant squared minus 1. Or just 3 tan theta. So put a box around my substitution stuff. And my integral turns into, let's see, dx is, oh, I left dx out. This right here where I've got 4, it's supposed to be 4 dx. So my dx then, dx is going to be 3/4 of secant theta tan theta d theta. Now, I could leave it written like that, but I'm not going to. Instead of writing 3/4 as a fraction in the top, I'm going to write the 3 up top and the 4 on the bottom. And then the radical gets replaced with 3 tan theta. All right, so what cancels? The 3's cancel, the tans cancel, and we're left with 1/4 integral of secant theta tan, or of just secant theta d theta. Now, secant is kind of a tough one to integrate, but it's one of the things that we have on the formula sheet that I gave you last week. Let's see, if I just read that off of here, secant theta, the integral of secant is ln of secant theta plus tan theta. And now we've got to put this back in terms of x. Now, the secant we could get just by solving this over here for secant theta. Secant is going to be 3 over 4x. I'll just write that beneath it. 3 over 4x. Or no, that's wrong. 4x over 3. Yeah. Divided that the wrong way. 4x over 3. But to get the tan, we've got to draw the triangle out and look at all the sides of the triangle. So let's do that. I'm going to come down here and draw my triangle. And what does this say? Well, it says secant theta is 4x over 3. Yeah. Okay, now what is secant? It's the reciprocal of cosine, so that means it's hypotenuse over adjacent. So let's see, the hypotenuse is 4x. The adjacent is 3. That makes this side over here 16x squared minus 9. And again, no coincidence, that's the radical that showed up in the original problem. Okay, so if that's secant, what do we need? We need tan. So tan theta, that's opposite over adjacent. So it gives us this. So I can rewrite my answer as 1/4 ln of 4x over 3 plus square root of 16x squared minus 9 over 3 plus c. And it's perfectly fine to leave my answer like this. However, that's not how the book is going to have the answer written. If this problem were in the book and you looked at the answer would look like this. And the big question there is, what happened to the 3? Well, if you want to pause and think about it for a second, you might be able to figure that out, especially if you think back about your logarithm rules. But let's let me show you what's going on between these two steps. All right, so since both of those have the same denominator, we can rewrite this as 1/4 ln of absolute value of 4x plus root 16x squared minus 9, all that over 3. And I want to do one other thing here. I've got the absolute values, but I'm going to change them so that they're only over the numerator. And that's perfectly fair to do because the denominator is positive. So we can do that. And now remember, we have a log rule that says if you have the natural log of a over b, you can rewrite that as natural log of a minus natural log of b. So if I use that rule, I get 1/4 ln of 4x plus square root of 16x squared minus 9 plus, well, let's see, minus ln of 3 plus c. But ln of 3 is a constant. And if we've got a constant of integration added on the end, we can just absorb that negative ln of 3 into the constant. So we can get rid of it and just write it as 1/4 ln of 4x plus square root of 16x squared minus 9 plus c. So that's the best way to write the answer.